Welcome to free engineering tutorial on operating system. So in previous video we had discussed about deadlock avoidance technique. Now in this video we will go deeper into deadlock avoidance technique and discuss an algorithm related to it. The algorithm name is Banker's algorithm. Why its name is Banker's algorithm is that as like bank it will keep the record of all the requested allocated records and what are the maximum records which a process can allocate or can request in its lifetime. It will all be made track of in this Banker's algorithm. So let me change the pointer option. Yeah, so there are two types of algorithm which we will discuss under Banker's algorithm. So these two algorithms are safety algorithm and the other one is resource request algorithm. So firstly I will discuss safety algorithm and quite a bit later I will discuss resource request algorithm. So firstly in the first step of safety algorithm we have to make finish array, means the visited array. You can say that in algorithms language this finish array is a visited array, and whichever we are visiting the process we will make, if we are allocating the resources to the process we will make the entry of that process as true. Okay, the second thing is we will make a single dimensional work array. Okay, so what work array is that at any instant of time what are the resources which are available at that instant, this will constitute a available array. Okay, so this ABC means there are three instances of A, three instances of B and two instances of C which are available at that instant. Okay, so in initial three resources of A, three instances of A resource, three instances of B and two instances of C resource are present. Okay, this much is clear. Okay, so the next step is we will make the full finish array as false, which means no process is yet assigned with the resources. Now there comes a second type of array which is need array. So what this need array is that at any instant of time how much resources a process needs. Okay, so that will be stored in need array. Now for calculating need array, because it will not be given in question, so we have to calculate need array. For the calculation of need array we have to require two additional arrays which are known as max and allocation. Okay, so max is the maximum amount of resources which a process needs in its lifetime, and the allocation is the one which a process currently has already. Okay, if the process currently has 010 record already, then it will be stored in allocation. Okay, so the next step is also clear. Now the third step is we have to make work equal to work plus allocation by checking the some conditions which I am going to talk about. Okay, so let's make need array. Okay, so firstly how will we calculate need array? Just make the difference of maximum and allocation. Okay, what means by maximum and allocation difference is that this is the maximum amount of resource which a process needs, and this amount he is already having. So how much it needs? Maximum minus allocation. Okay, so 7 minus 0 is equals to 7, we know that. Now 5 minus 1 4 and 3 minus 0 is equals to 3. So in the similar way we can calculate 3 minus 2 1, 2 minus 0 and 2 minus 0 is 2 2, so double 2 1 double 2, and 9 minus 3 6, 0 minus 0 is 0 and 2 minus 2 is also 0. So it needs, the process 2 needs 6 references or 6 instances of resources. In the same way full need array is calculated. Now in the next step we will check whether this process is visited or not. So in initial it is totally not visited. Okay, false. Yes. Now firstly it will start from process 0 and we will check whether it is been assigned, it is already assigned with the resources or not. So initially it is not, so it will check whether 743 is smaller than available or not, which means what we need is smaller than available or not. In other words, we can also say that whether the available resources which are there with the system can fulfill the request of the process. If it is not, then move to the next process and check the same thing, whether the process 1 is visited or already been assigned with the resources or not. So in this case it is not, then it will check whether what it is needed is available with the system or not. So as you can see that 1 2 2, first of all I want to make it clear is that these records are not 743 122, these are simply the instances of the resources and should be read as 122. Okay, so now we will check that 122 is smaller than 332, and yes, we encounter with the true condition, means 3 is smaller than 1, false. 3 is smaller than 2, false, means all are this available is greater than 122 and can able to fulfill the request. So we will make this process as true, and in the next step we will add the already allocated part to the available. Okay, why we are doing this? After completion it will all be over, so whatever it is already holds, it needs to release. Okay, so after releasing it will be added, this allocation part will be added to the available. Okay, so now this 332 will become 532. Okay, and let's make the sequence. So the process 1 will be allocated. Now we will go to the next step and we'll check. Okay, so we are here and we will now check whether 600 is already visited or being assigned by the resources or not, and we can see that this is false. So we will check whether it can be allocated by the resources among the available or not. So as you can see that 6, it needs 6 instances of A, but the system currently have only 5 instances, so this request will not be fulfilled and we will simply go to the next process. Now in this condition we will check whether process 3 is already being assigned. No, it is not being assigned. So now we will check whether 011 is smaller than 532 or not. So yes, we can say that it will be fulfilled or this request will be fulfilled. So now we will add this 211 to this 532. So now this 532 becomes 7, 4 and 3. Okay, and now this will become true, means it has already been allocated, and we will make it in sequence. Now process 3. Now we will go back to the next process and again check whether it is being allocated already or not, and as we can see that it is not been allocated, so we will check whether 431 is smaller than available. So yes, we can see that 743 is greater than 431. So now we will assign the already allocated part 002 to 743, means it will become 7, 4 and 5. Okay, and this will be assigned as true and it will be added to the sequence process 4. Now we will again go back to the first entry of the need array and we'll again check whether this process is being assigned already or not, as in this case process 0 is not assigned yet. Then we will check whether 743 is smaller than 745, and bingo, we are getting 745. So we will add this 010 to this 745 and we are getting the answer as 755. Okay, and we are adding this process with the sequence process 0 and then it will be made as true. And now we will check whether the another process, so here we will encounter that it is already been assigned, so we will not check further and go back to the process 2. Okay, so now we will encounter that process 2 is not yet assigned, and now we will check whether 600 is smaller than 755, and yes, it is smaller than 755, and will be assigned. So 600's allocation part, which means 302 will be added to 755, which means 10, 5 and 7, and this process 2 will be made as true. Okay, and it is already also been added to the safe sequence. Now this sequence what we are getting is called safe sequence. Okay, safe sequence. So this is all about safety algorithm. Okay, now we are getting another type of thing, like if now any process is requesting any other resources, means 102, will it be allocated in a safe sequence manner or not? Okay, so for this process we are needing another type of algorithm which is known as resource request algorithm. So I think I should explain this algorithm in next video. Okay, so till then, thank you.